Alrighty, welcome back to the Algebra 1 videos. In this one, we've just finished looking at systems of equations, and now we're going to move on to inequalities. First, single inequalities, and then systems of inequalities. So, at the beginning, we're going to look at just how to solve a one-variable inequality, and it's actually very similar to an equation, except instead of an equal sign, you're going to have a less than or a greater than sign. So, the way that you solve it is going to be exactly the same as if it was an equal sign. So, you used to have something like 2x plus 3 equals 5, and you'd work backwards by following the golden rule. You know, you'd subtract 3 from both sides, and then you divide 2 by both sides. Now, with an inequality, you might have something like 2x plus 3 is greater than 5. And you follow all the same steps. You work backwards following the golden rule, undoing steps one by one. And everything is the same as solving an equation, with one major exception. So this is a huge important exception, and we'll explain why it's an exception. So if you multiply both sides or divide both sides by a negative number, doesn't matter how big or how small it is, but if you multiply or divide by a negative, you need to flip the inequality sign. What flip the inequality sign means is if it used to be like a greater than sign, it's now going to become a less than sign. So if it's greater, it goes to less than. If it's less than, it goes to greater than. And the reason you have to do that, if you want to kind of imagine a number line, we'll just explain this real quick. Imagine a number line. Here's a 0. Say you start with a 2. If you multiply 2 by a negative number, not only does the value of it, 2, if say let's say are multiplying both sides by negative 3. So we're timesing both sides by negative 3. The number 2 times negative 3 is negative 6. So you're way over here at negative 6. So you're not actually getting bigger, you're getting smaller. So you've kind of crossed over. Instead of getting bigger and bigger, you're getting smaller and smaller and smaller. So that's kind of a conceptual way to see. When you multiply by a negative, you're flipping over the origin. So instead of actually getting bigger, you're getting smaller. Okay, so how do you graph the answer? Well, once you've solved your inequality, you'll have some kind of answer. Instead of being x equals 5, you'll have x is less than 5. Or maybe x is greater than or equal to negative 2, something like that. So the way that you'll do those is you'll draw a number line labeling 0 and your answer. So you'll have a number line just like I've done there. You'll label wherever the 0 is, and you'll label wherever your answer is. Say it was 5. Then if your answer is included, so greater than or equal to, or less than or equal to, the way that you show your answer itself is included is by plotting a point at that position, so a nice solid dot. But if you want to just do things that are greater than that number but not include it, then you would need to do an open circle. So an open circle, if we were doing a different problem, negative 3, an open circle would just be a circle around that number. And then you draw an arrow or shade to the left or the right, depending whether you're greater than or less than. So if you're greater than, you're going to shade off to the right this way. If you're less than, you're going to go off to the left that way. Okay, let's do an example. Let's do just one quick simple example. Let's do the one that I had on there before. I had 2x plus 3 is, I don't know, greater than 5. So your first step is to subtract 3 from both sides. Cancel that out. Then you have 2x is greater than 5 minus 3 is 2. That's just a greater than. Then you divide by 2, and you get x is greater than 1. To graph the answer, you make your number line. You plot your point 0, and you plot your point 1. Notice I don't have to put increments for all the other points. Really all that's important is plotting where your answer is relative to 0, so we can see if it's positive or negative. And x is greater than 1. So the 1 itself is not included, so I do an open circle. And I'm shading to the right because x is greater than 1. So numbers that are bigger than 1 are over here. And if you have colored pencils or a marker, maybe doing the circle and the shaded line in a different color could be really helpful. Okay, let's do one example where we have to worry about that negative sign. So maybe you've got negative 3 times x plus 1 is greater than or equal to 6. Okay, you have two choices here. The first choice would be to distribute the 3 in. The second choice would be to divide both sides by negative 3. So let's divide both sides by negative 3. Divide by negative 3. Divide by negative 3. The negatives 3 cancel. Here we're left with the x plus 1. Because I divided both sides by a negative, I have to flip this inequality. So now instead of greater than, it becomes less than or equal to. And 6 divided by negative 3 is negative 2. Now to keep solving for x, I'll subtract 1 from both sides. Those cancel. And my final answer is x is less than or equal to negative 3. So again, to graph these, you plot your number line, you plot in your 0, and your answer, which in this case is -3. Because I'm less than or equal to, I'm including that value in my answer, so I make a nice solid dot at that point. And x is less than, which means I'm shading numbers that are smaller than -3, which are the numbers over here on this side. So numerically, or I guess algebraically, that's my answer, and graphically, that's my answer. And both of these answers convey the exact same information. So one is a graphical way of showing it, one is an algebraic way of showing it. Okay, one small addition to this section, and then we'll be finished. So compound inequalities. So compound inequalities are conditionals that either and or. So it's when you have more than one criteria, and you're either saying that in order to be the answer, you have to meet all the criteria, criteria 1 and criteria 2 and criteria 3, etc. And the or possibility, it's called a conditional, is you have to meet at least one of the criteria. So let me give you a real world example. To go on a ride at, say, a theme park, you might have to be over the age of 5, and you might have to be taller than 36 inches. So you have to meet both of those criteria to go on this certain ride. So that would be an and criteria. You have to meet both criteria. An or criteria might be something like to drive a car. Well, actually, this would be another and criteria. To drive a car, you have to be over 16, and you have to pass the test, and you have to complete driver's training, and you have to do this, that. So a lot of things in our real-world situations have a conditional, which is an and. There are more than one criteria, and you have to meet all of those criteria to be eligible. Let's think of something that's an or criteria. Let's see, to win, to win bingo, you have to get 5 in a row or the 4 corners. Maybe if you're playing 4 corners bingo, you can get the 4 corners or you can get 5 in a row. So there's 2 different ways to win, and you don't have to do both. You have to do one or you have to do the other. As soon as you've done either one, you're victorious, or your condition has been met. So with an and conditional, it's a lot more restrictive. You have your final answer is going to be a lot smaller. So what you're looking for is the regions that overlap. Okay, so if your first answer, let's draw a big number line. If your first conditional was x is greater than 5, and then you had and x is less than or equal to 7. So the first one, x is greater than 5. So let's put a 0 here, a 5 here, and a 7 here. X is greater than 5, so you're going to draw an open circle at 5, and you're going to shade that way. Then the and, x is less than or equal to 7. You're going to draw a closed circle at 7, and you're going to shade that way. So what's the only places where both of those criteria are met? You have to be bigger than 5 and less than 7. So the places in between them are the only places that are met. The value of 1, it is less than 7, but it's not greater than 5. And numbers over here like 10, they're greater than 5, but they're not less than 7. So the and conditional, you're only going to keep as your final answer the places where the 2 solutions, or 3 solutions, or however many there are, wherever they all overlap. With an or, as long as any part of the region is shaded by any of your solutions, so you graph all your solutions on top of each other, and as long as any part is shaded, that's part of your final answer. So a lot of times with an or, you'll get a couple of possibilities if you have 2 things. Possibility 1 is you'll have this one go that way, and this one go that way, in which case all of this is your answer, and all of this is your answer. So your answer would be everything except that empty part in the middle. But another possibility for an or is you have one of your answers looks like that, and the other answer looks like that, kind of like what we had right here. And in this case, your answer, this one here is covering everything to the left, and this one here is covering everything to the right. So your final answer would be all numbers. Okay, so that's just a quick introduction, get the idea of what a compound inequality is, the 2 conditionals and or, and also combining with the golden rule for solving inequalities, where you just do the same thing to the left side as the right side, with the one thing to remember that if you multiply or divide by negative, you flip the inequality, and that you use an open or closed circle depending whether the solution is included or excluded. Okay, that's it for now. We'll move on in the next video to solving multivariable inequalities.